Hi everyone, in this video I'm going to go over implicit differentiation using these two examples. The first example that we have is this, and we are trying to solve for the derivative of y with respect to x. You might remember this as y prime, and you can use this y prime notation, but I prefer this because it's more general and complete. So because we are trying to find the derivative of y with respect to x, then the first step is to take the derivative of both hand sides with respect to x. So we'll get the derivative of x cubed plus y cubed with respect to x is equal to the derivative of 6xy with respect to x again. Because we have a summation, it's going to be the derivative of the first plus the derivative of the second. On the right hand side, we have a constant. We can take it out of the derivative and we'll have the derivative of x times y with respect to x. Here we want to find all these three derivatives. Let's start with the first one. What is the derivative of x cubed with respect to x? Because the variables are the same, it's the regular derivative that you know, and according to the power rule, it's going to be 3x squared. Now, what is the derivative of y cubed with respect to x? Because the variables are not the same, then we are going to need to use the chain rule. And according to the chain rule, with the power rule, we will get 3 times y squared times the derivative of inside. And what do I mean by inside? I mean everything except the exponent. Because in this case, we had to use the exponent rule or the power rule, the inside for it would be everything except the exponent, which is y. And we had to apply by the derivative of the inside because of the chain rule. And on the right hand side, we have 6 times. Because I see a product between x and y, I want to call my x to be my first function, y to be my second function, and the product rule says it's going to be equal to the derivative of the first times the second plus the derivative of the second times the first. Okay, what is the derivative of y with respect to x? That's what I'm looking for. So this is the derivative of y with respect to x. And you can think of it as chain rule. According to the chain rule, it's what it is. And what is the derivative of x with respect to x? Think about this part as what is just the derivative of x? You would say it's 1, right? And that's true. This is equal to 1. So we have a 1 here. And what is the derivative of y with respect to x? It's the same question as here. That's what I'm looking for. We will leave it as dy over dx. Putting everything together, we have 3x squared plus 3y squared dy dx equal to 6. I will distribute the 6. So we have 6y plus 6x dy dx. Because we're trying to find dy over dx, I need to put these two terms next to each other. On one side, we get 3x squared minus 6y equal to dy dx times 6x minus 3y squared. And if we divide both sides by this term right here, we will get 3x squared minus 6y divided by 6x minus 3y squared. We could also factor 3 from every term and get x squared minus 2y divided by 2x minus y squared. And this is the final answer to the question. The next example that we have is a product on the left between y and sine of x squared and another product on the right between x and sine of y squared. And this time we are trying to find the derivative of x with respect to y. The variable of respect is y here, as opposed to x, which was in this case. So again, the same way, we are going to start by taking the derivative of both sides with respect to what we see in the denominator, which is y in this case. So the derivative of y times sine x squared with respect to y must be equal to the derivative of x times sine of y squared with respect to y again. We see a product between y, that's my first function, and sine of x squared, I want to call that to be my second function. And similarly, x and sine of y squared, my first and second functions. According to the product rule of differentiation, it's going to be equal to the derivative of the first times the second plus the derivative of the second, sine of x squared in this case, times the first, equal to, same way because we have another product, so the derivative of the first times the second plus the derivative of the second times the first. Okay. What is the derivative of y with respect to y? They are the same variable, so it's a regular derivative that you know. The derivative of x was 1 when it was with respect to x. Now I'm just changing the name. The derivative of y with respect to y would be just 1. So this is equal to 1. What is the derivative of sine x squared with respect to y? Notice the variables are not the same. We have x, but the variable of respect is y in this case. In addition to that, I see a sine of x squared, so I know that I need to use the chain rule anyway. So the chain rule says, start with the outermost function, and the outermost function here is sine. The derivative of sine is cosine, so we get cosine x squared times the derivative of inside, and inside in this case is the argument inside the trig function because that was our outermost function. The derivative of x squared is 2 times x times, because it's not with respect to x, we need to use the chain rule one more time. Let me rewrite this like this. So I want to find the derivative of, with respect to y, the derivative of x squared. Okay. Now, what is the derivative of x squared with respect to y? It's the power rule, but chain rule too. So 2 times x times the derivative of inside. And in this case, my inside would be x because I'm using the power rule. Inside the power is x. And lastly, we have the derivative of x with respect to y. That's what we're looking for, so we leave it the way it is. And the derivative of sine of y squared, because the variables are the same, this is a simple case, and it's the chain rule. The outermost function is sine, so we get cosine y squared times the derivative of inside, which is 2 times y. Okay, let's put everything together. We have 1 times sine of x squared, so sine of x squared plus cosine x squared times 2 times x times dx over dy times y is equal to dx over dy times sine of y squared plus 2xy cosine y squared. We are looking for dx over dy, so I want this term to be next to this term on one side. So we'll get dx over dy times 2xy cosine x squared minus sine of y squared is equal to 2xy cosine y squared minus sine of x squared. So dx over dy is equal to 2xy cosine y squared minus sine x squared divided by 2xy cosine x squared minus sine y squared. And that is the final answer to this question.